Oxman and I'm an architect. I came to MIT after I completed my studies at the Architectural Association in London and have worked for a few years in the industry in architectural firms. And I came here to do my PhD and then stayed as a faculty member. I direct the Mediated Matter group at the MIT Media Lab. And the Mediated Matter group is essentially focused around digital fabrication technologies that are inspired by nature. Basically, in nature, everything grows, right? We generate human tissues and animal tissues and even plants as substrates that are informed and infused with environmental forces, and then they grow to create their various functions. In architecture and design, we tend to work with elements that are put together to create a larger function. In the natural world, those larger functions are the result of growth. This is also what brought me to 3D printing to begin with. If we can generate tools or technologies that grow materials rather than subtract materials, then we can control lots of elements in that growth process. We can control material composition, and by controlling material composition, we can compute various functions into the same materials. I knew I was working with an additive manufacturing technology. So I knew I was working to begin with layers, with structures that would be designed and fabricated by consecutively layering basically very, very thin layers one on top of the other. And so that got me thinking about the relationship between those layers. How can we include other information inside those layers? Can we vary between material properties as a function of what kind of scales? Are we only looking into delineation of particular features of the model? Are we looking into varying the material properties as we would vary the pores of and on our skins? I think 3D printing has really brought about a revolution in design that is equivalent perhaps to the printing press revolution, to Gutenberg's revolution of movable type in the 1440s. I mean, if you think about it, the movable type revolution really allowed all of us to print books and to mechanize this process of democratizing information to anyone. And without a doubt, the 3D printing revolution is democratizing and revolutionizing the way we do fabrication. So if in the mid-15th century we could all read and write, now we can all make. And so the type of democratization of information that was enabled through the movable type and the Gutenberg revolution is now being enabled by the 3D printing revolution. And I think it's a big revolution. The 3D printing technology was extremely important for dreaming up this project. It wasn't about generating the form of those imaginary beings and then using the 3D printer to print them. It was really about using the multi-material technology as an opportunity to think about how to make those contraptions or wearable myths mythical, and how to actually make them work as better products or better objects for the human body. So this show that we're opening in Centre Pompidou in May 2nd is called Imaginary Beings, Mythologies of the Not Yet. And I should say that this work is really the fruit of a wonderful and long collaboration with dear friends of mine and dear colleagues of mine. Of course, friends at Objet and Conics, specifically people who have been working on the Cons 500, which through I think a period of a good 5 years. We've been working together and have been going through the various material developments and testing and implementation of some of these technologies in the design work that I've done. So this is from the technology side, but it should really mention two great collaborators on this project. The first is my good friend and colleague, Professor Craig Carter, from the Department of Material Science and Engineering. And another partner in this particular project was Joe Hicklin from the MathWorks. We had lots of ideas for where we wanted to go with this show. And some of these ideas meant that we need to develop the technological tools and the type of features that I wanted to capture in these new designs. But these new features were not yet part of the technology. And so part of the excitement around this show for me was really the opportunity to work with Objet hand in hand on these new features and to actually make them happen, to see them in physical form and to see them manifested in the physical objects which we'll see in the show. But really the combination between material science, computer science and biology yielded this show, this project, which now thinking about it and now I'm sort of reaching the end of producing and putting all the pieces together, I really and truly believe that this is really just the beginning of a project, and these models are just the proof of that this dream can actually be made possible. So all these principles in science, I wanted to find their analogies in mythology and to sort of use this as my fantasy playground to explore some of these ideas. And so the exhibit contains 18 objects, 18 wearable mythologies for the human body. So essentially they're myths that you can wear and that talk to the kind of amplification, the kind of superhuman powers that you gain by wearing those. Some of them are more practical than others, of course. Some of them remain at the realm of fantasy. One such example, for instance, is a series of helmets that's called the Minotaur series. And so the Minotaur series was really an exploration in the design of a shock absorbent helmet that could adjust itself to the form of the skull that it inhabits or which it inhabits. The Minotaur series explores how you can generate helmets which are responsive and dynamic using soft and stiff materials that can correspond with the kind of shock that, God forbid, you have to absorb. And so this was one such example. The corset was inspired by Arachne's myth. And essentially we were looking to design a spider web-like structure that would be filled with certain soft materials in the infill regions between the spider web. So imagine an elastic spider web filled with soft and stiff materials, stiff where you want the spider web to be static, not to move, to not have compliance, and soft materials where you want to have more elasticity, higher levels of compliance, depending on the kind of movement. And Joe Hicklin and Craig Carter and I were looking into reaction diffusion patterns and implementing some of those reaction diffusion patterns in using multi-material printing. So these reaction diffusion patterns, which are abundant in nature, they explain all sorts of principles in nature, and actually they're a great Turing model for various computational processes as well, is what inspired the form of the corset, and basically moving from inner softer materials to more external stiffer materials that vary in property and also vary in the kind of density of the wrinkles, the size of the wrinkles, etc. So 3D printing is this currently this new frontier of digital fabrication. But when you think about it, these technologies, certain technologies that help us or make our life better, more efficient in some way, they come and go every 5 or 10 years. Technologies that actually make a difference, that actually generate a paradigm shift, they don't come that often. And I believe that 3D printing is one of those technologies that has created this paradigm shift. They say that when you're inside the paradigm shift, you can't see the shift. So I think we're still inside that kind of tunnel, that kind of hurricane. So we're not seeing it, but I think again, like Gutenberg's revolution You know, the 212 is the new 1440s, and I think it is a revolution that is perhaps a destructive technology more than anything else, because it really changes the way we think about production, the way we think about consumer products, and about democratizing processes of designing and making. That is not to say that I truly and utterly believe in democratizing all of design, but it definitely affords everyone, all of us, with these possibilities. So I definitely encourage and people to look into that and to explore that as a method of thinking about making more than simply a service station, but really a way of thinking about the world and about making and fabricating in the artificial. And I don't think this kind of work would have been brought to fruition without the MIT Media Lab, and of course without Objet and their support with the multi-material printers. So I'm very, very thankful for the opportunity to be in this nexus. I'm extremely excited to attend the opening, and excited about the prospect of showing the work that my colleagues and I have been working on for so many months. Mostly, I'm excited about the possibility of dreaming, and the possibility that one might really turn into physical, material form any poetry that resides in the mind.